This is the waterproof holes and bubbling water experiment. Waterproof holes, that's a bit strange. We're going to find out why. You can see the things we need in front of me. I have a bowl here, a glass. Now I am using a glass because I want you to see what's happening inside. I actually recommend you use, say, a plastic cup, something else which is less likely to break if you drop it. A hanky, just an ordinary handkerchief. Okay, that's what I'm using, one of my favourites, red spotted one. Jug full of water, or with water in, not quite full up, and a couple of elastic bands. I've got quite a few here, but I only need one or two of these, so I'll leave those there. First, we're going to see if a hanky is waterproof. Will it hold water? If we make a little hole in it, could it hold water inside? Or will the water pour through the little holes that may or may not be in it? Let's find out. I wonder what you already think. But I'm going to do this for you and show you what happens. I'm going to push my fingers down inside like that to make a bit of a funnel shape. Okay, and so you can see what's going to happen. I'm going to lift one edge up a little to make it easier to see what's happening in the water, so you can see where it's going, though I think it'd be difficult to explain where it's going otherwise, but at least I'd like you to be able to see it with your own eyes. And now let's see if the hanky is waterproof or not. If it's waterproof, none of the water will go into the glass because it'll be held in the handkerchief. If it's not waterproof and the water pours through holes, then of course the water will go down into the glass. Let's find out. Okay, well, it's going into the glass, so I'm sure most of you would have predicted that with no problem at all. Okay, so that's the first part of the experiment, which is pretty simple. I'm going to put that back down again. What I'm going to do, and what I want you to do, is pull the hanky up a bit so that it's only just bending into your glass just a bit, just dipping down a little bit, okay? That's the first thing I want you to do. And then next thing is a bit more fiddly, so you might want someone to help with this and ask them to hold the cup you're using nice and firmly while you do this. You need a couple of elastic bands. This is one way I'm going to do it. Some people prefer to use string for this, but I'm going to use elastic bands. I like using elastic bands, and in fact this is quite a thick elastic band. Sometimes I use a couple of elastic bands together like this because it makes it a bit stronger. So make sure you've got some sort of strong elastic bands. I'll use those two now I've got them here. I'm going to cross them over so I know they're going to be even stronger. Make sure they're nice and strong. And I'm going to put them over the top of the glass. And in your case, remember, you may have an ordinary cup. Make sure it's strong enough, don't want to squash it in, but maybe get someone to hold it. Hopefully I won't need them. Let's find out. And I'm going to put it over the top like that to hold the hanky in place. So it's a bit like a saggy drum skin in a way, isn't it? That's one way of thinking about it. So we poured the water through the handkerchief. You saw that happen. You could have predicted that, I'm sure, without me even being able to do it. What I want you to do is take your bowl, or whatever you're going to use, a bucket's fine. Of course, you could do this in the kitchen over by the kitchen sink and just do it into the sink, that's fine. And what I want you to do is take the glass, turn it upside down and pour the water out back into the bowl. Okay? See what happens. Okay, let's see what happens with mine. Before I tip it, notice I've got a little bit of water just sloshing around in the top because I filled the glass almost to the top, so it's actually already coming up through the hanky. If I lift the hanky up, you won't see it there. So the hanky is actually draping into the water because it's nearly full up. So let's see what happens when we go to pour the water out of the hanky. Not much. In fact, all we seem to have lost is that little bit of water that was just sloshing around in the top. If I take my hand away now, look, it's all still there pretty much. Hardly any has come out. Totally weird. Now what I'm going to do, I'm going to grip it from the top. I want to show you something more interesting. Well, not more interesting, differently interesting, I think is a better word to say. So far that's pretty interesting. Why isn't it coming out? It went through okay. How come it can't go back out the other way? How come these holes that are in the handkerchief appear to be waterproof now? They weren't the other time. I want to show you something else. What I'm going to do, I'm going to put my hand up inside, and where it is bulging into the glass, remember I said to leave a little sag? Well, of course it's upside down now, so it's bulging up into the glass. You can't see that very well right now, but it is bulging up. The hanky is bulging up a bit. I'm going to grip that bulge from underneath and give it a little tug to make it tight, so it's not so bulging and it goes more like that, okay? Watch what happens. So we get bubbling water. When I let go, look what comes from underneath. A little bit of water comes out. Just pull it again to stretch it. Let go again. So remember what I'm doing, I'm pulling that bulge that's still coming up into the glass a bit, and I'm stretching it straighter, like a more straight drum skin. Watch again. So here we have bubbling water. And it looks like it's boiling, doesn't it? So you could call this the boiling water trick. What is going on? So what's going on with this one? Well, a couple of things to explain. Let's think about the first part. We poured the water through the handkerchief, went through the holes in the handkerchief. They're very tiny holes. If we held that up, we wouldn't be able to see them with our eyes. But if we had a very good magnifying glass, or better still, a microscope, you might just be able to see them. The water flowed through that no problem. The particles of water, the molecules of water are easily small enough to fit through. Otherwise it wouldn't have gone through. However, when we turned it upside down, a little bit came out. It was actually resting on the top anyway, most of it. But almost all of the water actually stayed in the glass. As you saw, it stayed pretty much there and nothing happened. It would have stayed there and it would still be now had I not played around with it. Why didn't it come out? Well, when we turn it upside down, the weight of the water being pulled by gravity, remember gravity is pulling everything down, the weight of the water is being pulled by gravity and is pushing down against the handkerchief. And of course it's trying to come out through those holes. As the water was weighing down, it was stretching the little gap that was here and making it bigger. And of course, making it bigger, it was already full of some air. If we make it bigger, the same amount of air has to spread out and move into a bigger space. And when that happens, the pressure goes lower. So we lower the pressure. Now the pressure goes so low that it's actually much lower than the pressure of air outside. So lower pressure in there, higher pressure outside, and the higher pressure air surrounding us right now is pushing up against the underside of that handkerchief, which is making it bulge up into the glass. So the higher pressure air outside is actually stopping the water escaping. Another way of thinking about that actually is to think, I'll ask you to do a thought experiment now. If you had a big bottle full of water and you poured that bottle into a bowl, as the water comes out, you see lots of bubbles going back in, wouldn't you? So in other words, for the water to escape the bottle, it normally gets replaced by bubbles coming back in. It normally happens quite easily with a big bottle, but the water is trying to get through the holes here, the ones it came in through, no problem, but it can't get out because the air's stopping it. So the water gets held in by the air from outside. One other little factor, water, where it meets the air, will form a little layer or a skin called a meniscus, and it pulls in all directions, a bit like a drum skin, it's pulling in all directions. And that is also helping to stop the water flow through the holes. So that little meniscus layer, which is forming between all those thousands of little holes that are in this handkerchief, it's stopping the water coming through any further as well. So two main things, the little meniscus layer, which is forming where the water meets the air as it's seeping through the handkerchief because it still feels wet underneath, and the pressure of the air from outside is stopping the water escaping. So that's the first thing. So how come we had bubbles form when I was stretching that bump so it wasn't bumping so much and going like that? Well, remember what I told you? The air pressure from outside is higher than the air pressure in that gap there, right now. That's why the water isn't leaking. So right now the air pressure outside the room is higher than that, okay? When I do that, I make that pressure even lower than it was before. And now it's gone so low that the air from outside can actually push in. It's so much higher now. The difference is increased, in other words. So it was low anyway, but by pulling that piece of cloth like that, making it flatter, it's made that space even bigger. That drops the pressure even lower than it is now. So the difference between inside and outside is even more, and the air flows in to balance it again, or try to balance it again. And that's why the air gets sucked in through those holes effectively. Actually, it's not getting sucked in, it's pushing in, but it looks like it's been sucked in. So that's how come the bubbles come through. Okay, so what other things could we try? Well, I've used a handkerchief on this one, haven't I? You may not have a handkerchief to use. So how about trying other cloth instead? The handkerchief I've used has got what we might call a very tight weave. the fibres that have been used to make it. It's made of cotton, this one, so the cotton fibres have been weaved or woven very tightly together. So how about trying to find a piece of cloth that has a very tight weave like this, or maybe other sort of cloth where you can actually maybe see the holes even. So they're so big you can see them. What would happen? For example, what about a tea towel? That might be interesting. Try a tea towel. Or a bath towel. That'd be worth trying, wouldn't it? Or maybe a face washing cloth or a flannel that you might use to wash your face with. Or maybe, if you're happy to use it, maybe a piece of a t-shirt or a pair of trousers that you're happy to get a bit wet. It's only water, remember, so it shouldn't do any damage. Other things. What about using different size containers? Some of you may well have one of those great big plastic ones, about a litre or more, actually I've seen them. So great big plastic containers. Do a similar thing with a much bigger volume, in other words. Fill it right to the brim like we did this one. Will it still work? Do you think the heavier water will push through this time, or will it still stay there? In fact, if you're going to go for big things, why not find something that big even? Or even a small saucepan. Of course, however big it is, your handkerchief or whatever cloth you're going to use will have to fit around the top, and you're going to have to make it airtight. That's what the elastic bands are doing. You're going to have to put it on. Something like this, it probably would work. They would have to put it underneath the spout on a pot like this, or a jug like this. I'm sure you can think of other sort of containers. Of course, I started off with the water full up. Is that important? So start off maybe with half or hardly any and see what you find out. See if you can think of some other things.